Welcome back, me, Mr. Treewin. It's part 2 of reflections. We finished up yesterday with part 1, and we finished on this example right here. And like I said yesterday, or in our previous video, that I wanted to re-examine this problem before we got started on the new material, because there's a couple things about this I wanted you to notice about graphing over a specific line. So the question asked us yesterday to reflect over y equals 2, and we were supposed to reflect points A, B, and C. So A, B, and C, I've drawn out the triangle in black here, A, B, and C. And I drew those points out, and then for step 2 of this process, I went ahead and drew the line y equals 2, which again, in algebra, when they say draw y equals 2, that means draw a line that crosses the y-axis at the number 2. So if you cross the y-axis at 2, you got that dotted line. So that's what I drew, that's my line of symmetry. And then when I reflected over it, I told you yesterday that we were counting away from the line. And so because the line was horizontal, we count vertically up and down. And since like point A here was 1 unit under the line of reflection, that means that A prime, the reflection, the image, will be 1 unit above. And then the same thing went with points B and points C. And we ended up with, this was the result. This was our image right here. And in the image, you see these numbers. And what I wanted you to do yesterday, I mentioned, is that we were going to start off by kind of looking at these two numbers and seeing how they're related. And the reason I'm asking you to do this is, if I were to give you just those two sets of numbers and then turn around and ask you for the line of symmetry, how could you figure it out? Well, one way is if you look at the numbers closely, there's a lot of information that you can gather about the line of symmetry. For example, if I look at A pre-image and A image, I notice they're the same number, which means X is not changing, which that tells me a little bit about what's going on, because I know that I'm not changing my X values. So I am not changing how far to the left or how far to the right I'm moving, because I'm staying in the same place. If you look at these, 1 is 1, -2 is -2, and 0 is 0. Meaning, when I drew these out, I never moved left and right, which tells me that I must be doing something vertically up and down. So I know that I'm changing from the one position up and down. Now, if I look carefully at the y values, that's where I can get the line of the equation. And I do this using the midpoint. So I'm just going to make a little side note off of here, but let's look at the midpoint if I take these two numbers. So I know that x's don't change, but when I look at y's, I went from +1 to +3. Well, if I use the midpoint formula, I'll just do it right here. Midpoint. Remember, that's 1 + 3 divided by 2. 1 + 3 is 4, and divided by 2 is 2. Let's try that with b. -1 + 5 divided by 2. -1 + 5 is 4, and divided by 2 is 2 again. Do that one more time. 5 plus -1 divided by 2 is 2. So that tells me when I look at them, it must be y, because that's what's changing, y equals 2. So I know the line of reflection is y equals 2. And that happened to be what it was from the get-go. Now, obviously, I told you that from the beginning, but if I were not to have this and instead just give you two sets of numbers, I think that you should be able to figure it out by looking at the numbers and trying to figure out how they change. So in this case, to wrap that up, x's didn't change, only the y's, which let me know that I need to look at the y values to figure out the line of symmetry, which ended up being y equals 2. All right, that takes us to our last two examples related to reflections. And these are not going to be easy ones. I'm going to be quite honest and upfront, because there's always this little stumbling when it comes to graphing this. So we're asked to graph A, B, and C, and then we're asked to reflect it over the line y equals x. And a lot of people just have a hard time understanding that that's actually a line. And it's because there's the absence of numbers, I think, create a little bit of an issue. So when I say y equals x, that means if we really want to write it out, you could say that that is like y equals 1x or 1 over 1x. And that is a diagonal line that goes up the page. It starts at, because there's no b value, it starts at 0. And it goes up 1, over 1. And it looks like this. This is the graph of y equals x. It's just, when it's not in that whole y equals mx plus b, that with numbers you get a little confused. So once I do that, I will now show you what to do, but you first have to figure out how to graph it. So I think we've covered that. Now, step 2, let's plot our points. Let's plot the pre-image. So it says 1, 2, that's here. 3, negative 1. Negative 3, negative 4. All right, so I'm going to connect this up. All right, so I'm going to be reflecting over a line that goes diagonally, and it's a little tricky on this one, but there's actually a formula for it, and that's why I have it written over here on the side to help us put that on our foldable for class. So the rule is this. When you want to reflect over the line y equals x, or y equals 1 over 1x plus 0, if you wanted to have it in slope-intercept that you would recognize, if you wanted to do that, the way you achieve that is, to do that, you take the x and y values and you simply reverse them. So I'm going to write that out for you, and then we're going to plot it out to see how it looks. So a would be 2, 1. B would be negative 1, 3. And C would be negative 4, negative 3. So let's draw that and see if it comes out to what I think it's going to do. So let's see, over 2, up 1. So that's here. Just mark as trash. Okay, over 1, I'm sorry, negative 1, 3. So this was A, this is B, and then negative 4, negative 4, negative 3. Let's connect them together, see what we get. And if you look at it and take a step back, you can see that I have taken and reflected that right over this diagonal line. And that is how you reflect over y equals x, which is, again, a diagonal line going up the page with a positive slope of 1 over 1. Now, what do you think? Let's try to apply what we would do. Think about how we go from the 1 to its exact opposite, going down the page like right here. So this one I want you to reflect over the line y equals negative x. So again, thinking about that in slope-intercept, that means start at 0 and go down the page and just keep going down the page diagonally. And this is the line y equals negative x. I should have wrote that over here. All right, so now we're going down the page. So I'm going to draw my dots. 3, 2, plot out all my points. Let's see, over 3, up 2. That's A. 5, 0. That's B. Let's see, negative 1, 4. Let's see. Let's see, that's kind of an odd looking triangle, but okay. You can tell that I just pick random numbers when I do this. I don't put a whole lot of effort into it, so we'll see what happens. But if I follow the rule, I should take this very oddly shaped triangle and reflect over this line. So when we wanted to go up the page, all we did was take the x and the y and switch their positions. Well, when we go down the page, we're going to do that same trick, except what we're supposed to do is flip them and then what they call negate them, or multiply them by negative 1, or just plain out, if in simplest terms, switch the signs. So here we go. A will be, instead of 3, positive 3, 2, it'll be negative 2, comma, -3. B will be at 0, can't negate that, so I guess it just stays 0, but instead of +5, -5. And then the last one is C, so it's -1, 4, so when I switch it, it's going to be -4, and then since that's a -1, we need to use the other symbol and change it to +1. Now let's draw it out and see if I ended up doing this correctly. So the first one, -2, -3. And that's A prime. All right, next one, 0, -5. That's 1, 2, 3, 4, 5. That's B prime. And then the last one, -4, 1. So back 4 at 1. And that's a win, that's it. I flipped over that line, I did the reflection right over the line, and I just had to remember the rule, which you don't really have to remember the rule because I made you a foldable for it in a class. So if you write these in on your foldable right now, and I recap the ones from yesterday, if you write them in, I think you'll be good to go. That's it. Thank you very much. Bye.